Okay, boys and girls, we're going to get started. Thomas, can you take a seat? KJ, can you take a seat? Okay. As always, I want to tell you guys we have a camera today, but none of you are in view, so you are fine. We're going to do a little bit of comprehensive review of base 10 today, and I'm hoping to have you guys working for most of it, but we will have to do a slight review before we move on to the actual activity. So I want to start by putting two problems up on the board. We're going to do 3 and 2100ths times 100 and 3 and 2100ths divided by 100. Okay, this is something we did on our last test, and this is something we just learned how to do on Friday, but they are both related. Okay, so they are both related, but there is one key difference. Excuse me, boys in the back. Okay, there's one key difference. So would someone like to solve the problem on the left? Would someone like to explain how we solve the problem on the left? No. Okay, we move the decimal 2 places to the right, and so our final answer would be correct, 321. Perfect. Now, this is something we learned on Friday. What would we do with this problem on the right, Augie? Okay, so we go 1, 2, but what do we do here? Okay, we put a 0. So we haven't necessarily done a word form to that many decimal places, but what would our answer look like? Perfect. So this would be tens, hundreds, thousands, 10,000s. So it would be 321 10,000s. Again, that's not something we went to that far, but that is how you say word form. Okay. So the initial setup is very similar, but obviously we get very drastic answers. And there is a key difference to remember here. And one thing that you will be expected to do on, again, not anytime soon, but in the future, in this upcoming topic test, you're expected to be able to do both of these at the same time. So I could have some problems with multiplication and some problems with division. Okay? And you're going to have to be able to spot the difference and know when to go to the right and when to go to the left. But what I would like you to do now is I'm actually going to give you guys 2 minutes to talk with a person next to you. I want you to see if you could come up with an explanation for how to remember which way goes to the right and which way goes to the left. Okay? So when we multiply, we go to the right, and when we divide, we go to the left. But I would like you guys to come up with 1, the reason why we move those directions when those operations are involved, and 2, how are you going to remember that? Okay, so I'm going to give you guys 2 minutes to talk, and then I'm going to come back and hear, and then I'm going to regroup, and we're going to hear some of your ideas. Okay, go. Why goes to left or right, and then how you're going to remember that.
Maybe I think the way how I remember it is
Sorry about this.
one more thing.
Just like so, one why does it happen? Why does it go to the right or why does it go to the left? And then how are you going to remember it? So 2 things. Like what's the reason why when you multiply it goes to the right? When you divide it? I'll explain this later. You know we're looking at.
Yeah, multiply. You want to keep on adding in those numbers. Division, you want to subtract those numbers. I just found a way. Multiply, you want to add those numbers. And that's division, you want to subtract those numbers. It's the cheesiest, most complicated.
You guys have about 30 more seconds. 30 more seconds.
You made it.
What is it? Okay, so I want to hear a couple of examples of feedback from you guys. So first, I want some groups rather to explain why might it go to the right with multiplication and to the left with division. Okay, what is sort of the reason for that, Sophia?
Okay,
So not what's the way to remember, what's the reason for why it moves that direction?
we came up with because, so if you're doing
Excuse me, I want to hear only Sophia.
So if you're doing division, it's because the left's already taken.
The left's already taken.
But I'm not.
Okay. Okay, so, because the other is multiplication. Okay, but I want to, excuse me in the back, I can't hear you all talking. So I want to sort of hear, not just because the other one was taken already, what we've learned, but Gigi, why might, because I shared your hand up earlier, why might it go to the right for multiplication to the left for division? Like what? Okay, I did tell you that, but I want to see why, Charlotte.
When you're dividing, well, when you're multiplying, it's a whole number, so it gets the thing higher. So the number gets higher. The number gets bigger when outside the decimal, and that gets it outside the decimal. So with division, it turns to get smaller, and so it makes the decimal farther away from the number, so the number stays smaller.
Okay, so that one, the wording we can tweak a bit, but the idea you have is exactly right. Okay, so what Charlotte is saying here is that when you multiply by a whole number, we know that things get bigger. And when you move the decimal to the right, the value gets bigger. Do you guys see that? But when you divide by a whole number, things get smaller. So when you move it to the left, the place values get smaller. So if you guys are unsure, and if you're in a test situation or in a homework situation, and you say, can't remember which way it goes, think about what's happening to the number. Is it getting larger or is it getting smaller? And that will help you decide which direction to go. Okay. Correct. So yes, I would like to hear some possible memory tricks that you guys have for why you might be able to remember. Okay, Julia?
So for multiplying, you want to add the number, and then for division, you want to subtract it, like that.
But why does add go right and subtract go left? Okay, Charlotte? Guys, and the boys, I'm gonna have to move you guys if you can't control yourselves. Okay?
Left is less, and right is tight.
Okay, I like the idea of left is less. That's probably, so left is less and then right, you can just sort of say, well, it's not less. Yeah, Sophia. Excuse me. Yeah.
So division's like, not dies, but it like wants to leave the number.
Well, division and dies both start with D.
Yeah, so division died because it's leaving 3.21, so it wants to start over and wants to die and then be again.
Okay, if that helps you, that is awesome. Okay, we are going to move on. So we do an activity that involves both of these, and I just want to explain it before I pass these out to you because I think you'll be distracted once you have these. Okay. So what you're going to get in a moment, okay, I'm going to split you off into groups of 3. Do not worry about it yet. If you guys are talking, then I'm going to pick groups for you. You guys are going to get 3 sheets that look like this, okay? Now, what you're going to do first is I'm going to ask everyone in each group of 3, I'm going to give everyone a sheet of paper. This is why you have scissors. You need to cut out the triangles, okay? These are sort of like puzzle pieces. So everyone's first job will be to cut out the individual triangles. I'll put a recycling bin so you can put any scraps in the recycling bin, but you do need to hold on to everything else. What you will then have to do after we've cut it out, okay, is this is sort of like a puzzle. You will notice that on some of the triangle sides, there are numbers, and on some of them there are processes, like base 10 values, like times 100 or divided by 100. What you're going to have to do is you are going to have to match the problem to the value. Okay? So for example, if we were to have a triangle that had, let's say, on one side of the triangle was 3.21 times 100, and you were to have another triangle, and that triangle had 321, we know that 3.21 times 100 equals 321, so these pieces would go together. Okay, and it is all a puzzle, so it all matches up. Okay, so what you basically will have to do is you will have to solve the problems and find the corresponding values that connect to it. Okay, I will pass up some tape as well because you will need to sort of tape them together. But I would make sure that you're correct and you have to be working together to do that. Okay, so it will make sense, and I will come around and help you if that wasn't totally clear. But I think it will help to actually have these in front of you. But I'm going to move groups in a second. So we have 4, 8, 12, 14. Okay. So we are actually going to do 4 groups. Okay. We're going to do 4 groups, and I'm going to have us count. Okay. So we're going to do 1, 2, 3, 4, 1, 2, 3, 4. Okay. So I'll start with you.
1, 2, 3, 4. 1,
3.
4.
Okay, so if you are a 1, I would like you to move with your scissors, and not yet, with your scissors to this table. If you are a 2, you go to that table. If you are a 3, you go there. If you are a 4, you go here. Okay, go. 1, 2, 3. Okay, 1. 1, 2, 3, 4. Right here. Right here. Here 1. Okay. Let's please move. This should not take so long. Okay, so boys and girls, the first thing you should do is cut out the respective pieces. Okay, so there, you may need to want to cut it in half. That way you won't be cutting. So first, like, cut it down the middle, and then you take one half and turn it and take the other half. Yes, exactly. So make sure it's careful. So yeah, you're gonna cut it down the middle first, and then get one around.
Out of all of them,
Each, please cut off. So you want to cut off individual pieces. Each person has a piece of paper. Okay. You're going to cut off these triangles. So there are 3 sheets, but there are 4 of you. So I would say cut this one in half. You'll see you have half of it to you. You want to cut out the individual triangles. Okay. So each of you will get it, and you need to cut out the individual triangles. So I think cut off like that. That's just a start.
just to make it soft.
The base 10 stuff? I don't need to cut it. Yeah. We will eat our but not with. We'll get that. We will do fraction operations. It will make sense. You want to cut each one out. I'm going to put the recycling in the middle so that everyone can throw things in recycling. Where's your, can someone give a piece of, like, cut out part of it so that you can more of one? You know, scissors. Grab, I have it over here. I'll get some. Yeah, if you can cut that in half to give some to Lorena and Augie because they already done it there. Yes, get that so that you can cut half. And you can put, you can recycle the paper. Thank you. Okay, so as some groups are finishing, I do want to explain the directions. So even if you have not cut out everything yet, please look up here. Okay, each of these 4 groups has to work on one puzzle together. Okay, we are working on one puzzle together, and ultimately, all of these triangles will fit to make a hexagon, a 6-sided shape. Excuse me, guys, you need to follow these directions. You need to listen to the directions, otherwise it will not make any sense. In the end, all these triangles will come together to make a hexagon. Now, how to decide how these fit together? You will notice that on some of the sides, there are multiplication or division problems, and on some of the sides, there are just numbers. Okay? Your job is to match up the question with the answer. So if it were simpler, let's say it was addition. Okay? If you had one side